Hi, I'm s.l.dance. I'm a professor at the University of Reading, and my post is jointly held in the departments of Mathematics and Statistics and Meteorology. I'm interested in using mathematics to improve predictions and forecasts of hazardous environmental events like weather and flooding.
Hi, my name is s.l.dance Vetra-Carvalho, and I'm a researcher here at the University of Reading. I'll be co-supervising this project together with Sarah. And my interests lie in mathematical methods and how they can be used to improve forecasting, in particular in environmental problems. For example, in convective weather forecasts or urban flood forecasting.
So we're going to tell you about this PhD project, which is called Enhancing Forecasting Flood Inundation Mapping through Data Assimilation. Flooding is a really important problem worldwide. It affects people's lives, livelihoods, infrastructure, and the problem is only increasing. So by the year 2080, it's expected that across Europe, the cost of flooding will be around 100 billion euros, which is a lot of money. The state-of-the-art in flood forecasting uses a chain of forecasting models. So we take observations or numerical weather prediction weather forecasts of rainfall and progress them through a chain of models. That includes physical process models, things that describe hydrological processes, as well as probabilistic analysis, and that allows us to select from a pre-computed library of flood hazard maps. And that flood hazard map selection process is called a simulation library approach. And the reason we use that simulation library approach rather than computing things on the fly is that it's quite expensive numerically if you're producing forecasts over a large area. So what we would like to do is combine those forecasts with observations of the flood as it happens. However, the simulation library approach doesn't naturally lend itself to that, but there are lots of observations available.
Yes, so the observations of floods that we could have can come from various different instruments and all over different parts of the world. For example, satellite synthetic aperture radar, or SAR for short, is very good at imaging areas and we can derive floods from these images. In particular, it's very good because we can see through the cloud and also we can image areas over day and night. However, because of the orbit frequency of these satellites, we can at most get one or two such images over the area, and so we have a limited amount of observations in time coming from such an instrument. On the other hand, for example, CCTV cameras, we can get observations quite frequently in time, but over much smaller areas. In order for us to achieve the best flood forecasts, we need to combine these two pieces of information. So the information that comes from the flood models, so the computational models Sarah was talking about, and the observations. And so this comparison between the two pieces of information is the key aspect of this process called data assimilation. However, we need to think of the length scales these two pieces of observations, these two pieces of data provide for us. For example, you could think of area of average, and this could come from a computational model, information and data, and you could think of a point observation, and that could be, for example, a river height measurement coming from, for example, a gauge instrument in a river. So it is very important for us first to understand the length scales of the forecasting system in order to make this fair comparison.
Okay, so the goal in the project is to do three things really. One, with the spatial comparison, enables us to not just to make a better comparison of the observations with the forecast, but actually to improve interpretation of forecasts so that decision makers using those forecasts can make better decisions. And then secondly, we'd like to implement this idea of data assimilation, and that will help us, we hope, to actually improve the forecast coming from the simulation library system. And thirdly, because data assimilation has not been used before with this simulation library approach where we've got these pre-computed forecasts, we would like to develop a framework for using observations with this kind of simulation library system. Now, the student is expected to work in a kind of a mathematical way, so a lot of the ideas that we'll be thinking about will be generic. But at the same time, we're going to apply them across a range of case studies around the world. So some of the places that we've been thinking about using include the Brahmaputra River in India and Bangladesh, places in the UK, and also in the Republic of Ireland.
So this project is a collaboration between the University of Reading and JBA Trust, which is sponsored by the JBA. And JBA is an award-winning international and multidisciplinary environmental consultancy company. JBA will provide an expert's advice to you, as well as you'll be able to use their flood foresight forecasting system. And they will offer you an exciting opportunity to spend 3 months placement at one of their offices in the UK.
So we're looking for a really enthusiastic, highly motivated student and someone who's got good mathematical skills. So we'd like you to have a good degree in mathematics, physics, engineering, or another scientific subject with high mathematical content. The project will involve a certain amount of computer programming, so it would be really useful if you have some skills or experience in that area. But it doesn't matter if you don't, because we can always provide training. So if you think that you are interested in an exciting project using real flood forecast models with observations from real flood events and great mathematical ideas, this project is for you. And we'd be delighted if you got in touch, and we'd be delighted if you have any questions to address them for you.